A detector sat inside the Queen's chamber of the Great Pyramid, quietly collecting particles from the sky. The particles were muons, born when cosmic rays strike Earth's upper atmosphere. Most passed through the pyramid as if the stone were a thin fog. Some were absorbed by the limestone blocks above. The pattern should have matched the known rooms and corridors of the pyramid. Instead, the detector saw too many muons coming from one direction. That excess meant there was less stone than expected. Somewhere above the Grand Gallery, inside the body of the pyramid, there was a large empty space. The discovery was announced in 2017 by the ScanPyramids project. The space was at least 30 meters long. It was high inside a monument that had been studied for centuries. It had no known entrance. It had no known name from ancient Egypt. It had remained invisible since the pyramid was sealed into stone more than 4,500 years ago. Scientists called it a void. They did not call it a chamber. A muon detector can reveal missing mass. It cannot reveal a doorway, a floor, an inscription, or a purpose. The mystery began with a simple measurement. The Great Pyramid contained less stone than it should have contained. The Great Pyramid stands on the Giza Plateau west of modern Cairo. It was built during Egypt's 4th dynasty for the pharaoh Khufu. Most Egyptologists place its construction around the 26th century before the Common Era. Its original height was about 146 meters. Its base was about 230 meters on each side. For thousands of years, it was one of the tallest human-made structures on Earth. Its mass is mostly limestone. Its casing was once made of fine white limestone that reflected the desert sun. The visible shape is simple. The internal structure is not simple. A descending passage runs downward from the northern side into the bedrock. It leads toward an unfinished subterranean chamber beneath the pyramid. An ascending passage branches upward inside the masonry. That passage leads to the Grand Gallery. The Grand Gallery is a steep, corbelled passage about 47 meters long. It rises through the pyramid toward the King's Chamber. The King's Chamber is built from granite blocks brought from Aswan, hundreds of kilometers to the south. Above the King's Chamber are 5 small spaces often called relieving chambers. These spaces are capped by massive stones and a gabled roof. They appear to reduce pressure on the chamber below. Another room, traditionally called the Queen's Chamber, lies lower and closer to the pyramid's center line. Narrow shafts extend from the King's Chamber and the Queen's Chamber. The exact function of some shafts remains debated. By the 21st century, this internal plan seemed mostly known. The pyramid had been entered, measured, mapped, photographed, and scanned. There were still uncertainties. There were not supposed to be giant unknown spaces above the Grand Gallery. The surprise was not that the pyramid contained air. Ancient builders used gaps, corridors, and stress-relieving spaces in large stone monuments. The surprise was the size and position of the anomaly. The large void lies above the Grand Gallery. It appears to run through the same general region as one of the pyramid's most important internal passages. It is not part of the known route from the entrance to the King's Chamber. It is not one of the known relieving chambers above the King's Chamber. It is not visible from any known ancient passage. No explorer had walked into it. No early excavation had documented it. No surviving ancient text explains it. The pyramid was not a hollow building with many open rooms. Most of its volume is solid masonry. A space at least 30 meters long is therefore a major architectural fact. It would have required planning, or it would have resulted from a construction method large enough to leave a major gap. Either possibility matters. If it was designed as a structural feature, it may reveal how Egyptian engineers managed enormous loads. If it was a construction space, it may preserve evidence of how the pyramid was built. If it was a corridor or chamber, it may change the known internal architecture of the monument. The evidence does not yet choose among these possibilities. It only shows that a large, low-density region exists. Muon imaging works because the sky constantly sends particles through stone. Cosmic rays strike atoms high in the atmosphere. Those collisions produce short-lived particles that decay into muons. Muons travel at nearly the speed of light. Many reach the surface of Earth. They can pass through hundreds of meters of rock. Dense material absorbs or scatters more muons. Empty space lets more muons through. A detector records the direction of incoming muons over days or months. Researchers compare the measured pattern with a model of the structure. An excess of muons from one direction suggests a lower density region along that line. This method is sometimes called muography. It has been used to study volcanoes, reactors, and large archaeological structures. It is useful at Giza because it does not require cutting open the pyramid. The ScanPyramids team used several detector technologies. Nuclear emulsion films were placed inside the Queen's chamber. Scintillator detectors were used to record muons electronically. Gas-based detectors provided another independent measurement. The key point was reproducibility. Different instruments saw the same anomaly. The result was not a single blurred image from one device. It was a repeated signal from independent muon measurements. The measurements showed an unexpected region of lower density above the Grand Gallery. The detection did not provide a photograph of the interior. Muon imaging is closer to a shadow map than a camera image. It can locate a contrast in density. It cannot describe carved walls or objects inside. The large void is often called the ScanPyramids Big Void. The name is deliberately plain. It describes what the instruments detected. The void is located above the Grand Gallery. Its length is estimated to be at least 30 meters. Its cross-section may be comparable to the Grand Gallery, but its exact shape remains unknown. It may be horizontal. It may be inclined. It may be one continuous space. It may be several connected spaces that appear as one anomaly to the detectors. The available muon data cannot settle those details. The word void protects the evidence from speculation. A chamber suggests a room with walls, a floor, and a purpose. A corridor suggests movement from one place to another. A cavity could be accidental. A construction gap could be temporary in origin and permanent in result. The data show missing mass. They do not show human use. They do not show burial equipment. They do not show inscriptions. They do not show treasure. The void may be empty air. It may contain rubble. It may contain blocking stones. It may have features too small for current muon data to resolve. At the moment, its contents are unknown. The Grand Gallery below gives the void much of its importance. The Grand Gallery is one of the most remarkable internal spaces in the pyramid. Its high corbelled walls create a narrow rising hall of stone. It leads toward the king's chamber, the central royal burial space known today. A large void above this passage may not be a coincidence. It may have helped protect the gallery. It may have been created during the building of the gallery. It may relate to the movement of heavy blocks through the pyramid. Each idea is plausible, none has been proven. One leading explanation is structural. The pyramid is a mountain of stone built over delicate internal passages. The Grand Gallery needed to survive the weight above it. Ancient Egyptian builders already used stress-relieving spaces above the king's chamber. Those spaces redirect force away from the flat granite ceiling below. The large void may have served a similar function for the Grand Gallery or nearby passages. If this is correct, the void was not a hidden room. It was part of the engineering of the pyramid. Another explanation is construction. The void may be a remnant of an internal ramp, corridor, or working space used while the pyramid was being built. The mechanics of pyramid construction remain debated. Most researchers agree that ramps and lifting systems were used in some form. The details of those systems are still uncertain. An internal space above the Grand Gallery could record a stage in that construction process. A third possibility is architectural or symbolic. The builders may have created spaces according to religious or royal design principles that are not fully preserved in the archaeological record. This idea is harder to test unless inscriptions, associated objects, or a clear connection to known ritual architecture are found. There is also the possibility that the muon anomaly represents more than one feature. Several smaller spaces could combine into one larger signal. Irregular masonry or zones of lower density could complicate the picture. Researchers must separate geometry from interpretation. The strongest explanations will need to match the muon data, the known architecture, and the engineering constraints of the pyramid. They will also need to explain why the space is where it is. A theory that ignores the Grand Gallery is incomplete. A theory that assumes treasure without evidence is not archaeology. A theory that requires lost machines or non-human builders is not supported by the material record. The large void was not the only hidden feature reported by ScanPyramids. In 2023, researchers announced a corridor near the northern face of the Great Pyramid. This feature is often called the North Face Corridor. It lies behind the chevron-shaped stones above the original entrance area. Muon measurements helped identify it. A small endoscopic camera later confirmed an empty passage. The corridor is about 9 meters long. It is about 2 meters wide. It has a gabled ceiling made from sloping stone blocks. Unlike the large void above the Grand Gallery, the north face corridor has been visually observed. Images show a clean, narrow space with dressed stone surfaces. Its purpose is still uncertain. It may have been built to relieve pressure above the entrance zone. It may relate to an undiscovered architectural feature behind it. It may be part of a system of spaces used during construction. The corridor matters because it shows the value of cautious imaging. Muon data suggested a hidden space. Further investigation confirmed that the signal corresponded to a real corridor. The same sequence has not yet happened for the large void. No camera has entered the ScanPyramids' big void. No instrument has directly measured its walls. No sample has been taken from inside it. The north face corridor is therefore a warning and a promise. Hidden spaces can exist inside the pyramid. They can be detected without tearing the monument apart. Their purpose can remain uncertain even after they are seen. The Great Pyramid is not a laboratory object that can be cut open at will. It is a royal tomb, a world monument, and a fragile archaeological record. Every intervention can destroy context. Modern research must therefore extract information with minimal harm. Muon imaging is one tool. Longer exposure times can improve the signal. More detector positions can narrow the possible shape of the void. Improved three-dimensional models can test whether the anomaly is one space or several spaces. Infrared thermography can detect subtle temperature differences on accessible surfaces. Ground-penetrating radar can search for shallow features where conditions allow. Microgravity measurements can detect small changes in density. Laser scanning and photogrammetry can refine the known geometry of passages. Robotic systems may someday explore through existing cracks or openings if authorities approve them. Any direct access would need a clear scientific reason. It would also need a plan to protect the structure and the archaeological context. A small hole can answer one question while erasing evidence around it. The best evidence would be direct and contextual. A visual survey could show whether the void has dressed walls or rough masonry. Measurements could reveal its exact length, slope, height, and orientation. Photographs could show tool marks, blocking stones, debris, or construction features. Air samples might reveal whether the space is sealed or connected to other cavities. Inscriptions or quarry marks would be especially important. Associated objects would need careful recording and place. Only this kind of evidence could move the void from anomaly to architecture. Only context could show whether it was structural, practical, symbolic, or something else. The large void inside the Great Pyramid is not evidence for aliens. It is not evidence for a lost modern technology. It is not proof of a secret treasure room. It is evidence for a hidden architectural feature inside one of the most studied buildings in the world. That is enough to be extraordinary. The archaeological record already shows that ancient Egyptians could plan, quarry, transport, and place enormous quantities of stone. Worker settlements, tools, quarry marks, and administrative papyri all belong to that human story. Muon imaging adds a new chapter to it. It shows that the pyramid still contains information beyond the reach of ordinary sight. It also shows the limits of modern instruments. Science can detect a hidden absence. Science cannot assign meaning without evidence. The void may have protected the Grand Gallery from crushing weight. It may preserve a trace of the building process. It may represent an architectural choice whose meaning has been lost. It may be a combination of these things. For now, the pyramid keeps the most important details inside its stone. The builders created a space where later ages expected solid masonry. They placed it above a great rising gallery at the heart of the monument. They left no explanation that has yet been found. The question remains precise, ancient, and unanswered. The space is there. The reason for it is still hidden.
That's why Source. If this was worth your time, like it, share it, and tell me in the comments what you want examined next.